So dear students, so after a long gap, I'm here again. As I said, I was quite busy with the school stuffs. So I want to continue with what we were doing in our last classes. I think we were doing derivatives, and which we haven't introduced, or I haven't introduced it yet. Within it, what I did was I give you some concept about slope, and from the formula I have given, slope can be calculated by, for like any function given to you, slope can be calculated by the formula, that is change in y-axis divided by change in x-axis. So let us do some let's review what we did with an example. So let us take a function y is equals to 3x. You can take anything. Okay, I'm taking plus 2, and the graph will look like this. For this function, the graph looks something like this. For x is equals to 0, y will be equals to 2. For x is equals to 1, y will be equals to 5. For x is equals to 2, y will be equals to 8. For x is equals to 3, y will be equals to 11, and so on. So let's plot this. When you plot this, it will be 0, 1, 2, 3, 4, 5, 6, 7, and this side, this is x direction, and this is y direction. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. Okay, let's take 3 coordinates only. So 0, 2 is this point, 1, 5 is this point, 2, 8 is this point. So you'll get this kind of graph, something like this. Now you can choose any 2 points. So I'm choosing these 2 points because I know the coordinates of these 2 points. So now go from this point to this point without lifting your pen. So I'm going from this point to this point this way without lifting my pen. That means I came down first and I went left at the second. So when you climb down, along the y-axis. So your change in y-axis will be negative because you are going towards the negative y direction, because this is the up is the positive y direction and down is the negative y direction. So you're going down, that means you are going negative y direction. And how much value you are going down? You have gone from 8 to 5. That means you've traveled 3 values. So minus 3 is the change in y. Similarly, change in x will be, so you have gone to the left. So left along the axis negative and right along the axis of this positive. So you've gone towards left, that is delta x is negative, and by how much value you've gone towards the negative x? So 2 to 1, that means 1 value. So 1 is your change in x. So your slope is nothing but it is change in y divided by change in x, that is change in y is minus 3 divided by minus 1, that is 3. So your slope is 3. So now if I give you some more functions like y is equals to 2x plus 2, y is equals to 3x plus 4, y is equals to 2x minus 0, y is equals to 0x. So for this kind of function, if you see closely, what you see common is y is dependent on x in each case. Y is dependent on x in each case, and if y is dependent on x in each of the case, and okay, y is dependent on x in each case, but how much power does x, or how much power of x do depend on y in this case? So power 1, this power 2, power 1, power 1 and power 1. So at every case is like this. The y is dependent on the first power of x. So such graph is known as, or such functions is known as linear functions. So all these functions are linear functions because y is dependent on one power of x. So linear is actually, it's a line. It comes from line. So line to linear. So line means straight. Lines are always straight. So that's why at every cases like this you got a straight line. So this is the reason why you are getting straight line, because these all functions are linear functions. So because y is dependent on the first power of x. So for all such functions you will get a straight line graph. That is a linear graph. And even, okay, if you see closely at the example, y is equals to 3x plus 2 is a linear graph, so it is a straight line graph. And even, see, you've got the slope equals to 3, but 3 is somewhere here hidden. So this is 3. That means first letter, or first number which is multiplied to x is the slope itself. So 3 is the slope. 3 is the slope itself because 3 is multiplied to x. Similarly, for this graph, for this function, if you calculate, you'll get 2 as a slope. For this function, if you calculate, you'll get 3 as a slope. For this function, you'll calculate 2 as a slope. For this function, if you calculate 0 as a slope. That means for y is equals to 4x plus 5, what is the slope? Slope, you can, if you plot the graph, you can directly get slope equals to 4 because 4 is multiplied to x. So in general, this is a linear graph or a straight line graph. So if I generalize it, I'll get y is equals to mx plus c. So you may be familiar with this particular function or this formula. So y is equals to mx plus c is a linear function where m is the slope of this function, m is the slope of the function, x is a variable which is for which y is dependent on the x. So x is a variable with power 1 and c is your ordinate. So ordinate means if you see closely, 2 is the ordinate. So what is 2? 2 is the point at which this graph cuts the y-axis. So this graph cuts the y-axis at point 2. So this 2 is known as the ordinate. Similarly, if you plot this graph, you'll see the straight line will cut the y-axis at 0.5. It will cut the y-axis at 0.5 because 5 is the ordinate. So ordinate is the point or coordinate on the y-axis where the straight line cuts in the graph. So that is known as ordinate. So for functions like y is equals to 2x only, here c, the value of c is not there. That means the c is 0. So for such graph y is equals to 2x 0, the straight line will cut the y-axis at 0. So 0, y-axis 0 means it is nothing but it is origin. So this type of straight line will pass through the origin, but this type of straight line will not pass through the origin. It will pass through 0.5 on the y-axis. Similarly, this type of function will not pass through the origin because c, the value of c is non-zero. So this will pass through 0.2, the ordinate. So this is a brief introduction about slope of straight line. So what we dealt with is slope of only linear functions. So we did this. Slope of linear functions, we did this. But if you are given this kind of function, y is equals to x square, now this is no longer a linear function, because if you plot it, what you will get? If you see closely, y is dependent on the second power of x. So from the definition, it is not linear, because linear are such functions in which y is dependent on the first power of x, but here the power is 2. That means this is not linear. So let's see why this is not linear. So this is x, this is y. For x is equals to 1, y is equals to 1. For x is equals to 2, y is equals to 4. For x is equals to 3, y is equals to 9. For x is equals to 4, y is equals to 16, and so on. So when you plot this graph, so this is 0, this is 1, this is 2, this is 3, this is 4 on the x side, and on the y side it is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9. So 16, like it goes up and up, way up. So I'm just ignoring 16 here. So just plot 3 points. 1 1, this is 1 1, 2 4, 2 4, 3 9. So if you plot this graph from the origin, you will not get a straight line, but you will get a curve like this. So this is much steeper, because the x square function, like I've given like different, if you give a different scale, you can make it more flatter. So basically this functions look like this. This is x, this is y. So basically this function looks like this, and this is not a straight line, but rather it is a maybe parabola or hyperbola, whatever you call it. It is a hyperbola. So it is a curve. Now if I ask you, what is the slope of this function? What is the slope of this function? Y is equals to x squared. So how can you calculate the slope of this function? Like, you know, slope means steepness. Slope means steepness. So what can you say about the slope? That is steepness of the above function. So you have to answer it qualitatively. So you don't have to calculate anything, just give me qualitative answer about this. Qualitatively answer this question qualitatively. That is your homework. That is your homework for the next day or today. So this is it for today. So we are going to continue, and I'll ask ask everyone to give suggestions on the message that I've left you yesterday evening. So thank you.